Hi folks, what's on the board in front of you is a MERG Servo4. Beneath that is a 5-volt power supply, and in the lower right hand corner is a 4 relay module, and above that is 4 servos controlled by the Servo4. The Servo4 can control, well, you can set the limits of travel for the servos, and you can set the speeds in either direction independently, and you can make them go left or right depending on what you want in the on position. So it's possible to have servos going in the opposite direction to each other when you turn them on, and it's possible to have them going faster or slower in one direction or the other. And I'll just flick through them right now just so you can see that. Okay, you will have noticed the LEDs on the on the relay board light up as we went through that. The inputs to the Servo4 are all on when they're connected to ground. So there's 4 switches down the front of the board that have each of the inputs coming down and the ground return. I tried this interfacing mechanism instead of trying an alternate one from Davey Dick that I will talk about a bit later. But the idea was, okay, I've got a power supply that's not real good. It's definitely higher than 12 volts at no load, and even under the load on this board it's a bit over 14 volts. And just plugging in 12 volt relays to that, yeah, it would have worked, but it's not real great. So what I did was I put a 5 volt regulator in there and put 5 volt relays in there, and the Servo4 has actually got a diode in there only, as opposed to the rectifier bridge. And similarly I did the same thing to the power supply module. You can see just one diode on there instead of 4, so they have common ground. So when you look at the connections coming across from the bottom of the Servo4 onto the relay board, what you see is the ground goes to pin 1, and the only wire coming from the power supply is the line that goes straight onto the positive rail on that supply. It all works fine. You saw it go a minute ago. The only thing that happens though is that when I turn them all on, I've measured the current at about about a quarter of an amp onto that relay board from the regulator. With about 14 volts in, I've got about 9 volts dropping across that regulator on the small regulator in the middle there. That means that I'm dropping 2 and a bit watts continually out of that regulator chip for all the time that the servos are on. The servos are switched on, and therefore the relays are switched on as indicated by the LEDs. So right now that regulator is getting a little bit warm. Would it be okay? Yeah, probably. Those things will run to very hot. Do I like stuff running very hot? No. So the alternative method of doing this that I alluded to earlier was to use 12 volt relays down the corner here, power them straight from the supply, which in this case wouldn't be real pretty. I should put a regulator in. But that method requires you to put a diode on each of the inputs on the Servo4 board, as when you turn each of the inputs off on the Servo4, what you get is 5 volts on that line due to a pull-up. Well, the optocouplers on the relay board basically going 12 volts through a resistor through the optocoupler to whatever voltage the input is. So in this case we would have 7 volts across the optocoupler, and they may well never turn off, in which case the relays would always stay on and you would not achieve what you wanted. I didn't mention why the relays are there. In model railways, one of the things you need to do if you're using what are called live frog points is to manage the polarity of the common bit of rail at the frog to match the direction of the turnout. Now that can be done by switches connected to the mechanism that's changing the turnout position, or they can be connected so that they are rubbed on by the servo arm as they go. But to use the relay board was just okay. Can we do it in a cheap and electronic way? The thing is that you buy these servo boards for only a few bucks, which is quite amazing. Sorry, relay boards. That's about all I wanted to show. What I will do though is I'm not happy with how hot that little regulator board runs, so the next time I go about this I'm going to put a small switch mode power supply in there and see that it all works okay. That's it. It's a cruddy little video. I don't know how to edit this stuff, so I'm just going to put it up raw. Thanks folks.